Hello everyone, and then welcome to another tutorial video. Okay, so in this video we'll be treating what reversing order. So this is all about trying to reverse what the order of what an integral. So like interchanging the x with the y and then interchanging what dy with the s. It's vice versa. Okay, right. So in case you are new to this channel and you want to see more of these videos, I would urge you to subscribe to the channel, turn on your post notification by clicking on the bell icon so that you don't miss out on future videos. Okay, smash the like button so that this video gets pushed to other students like you who would need this video to help them augment their studies, just like somebody like this video and then you are watching this right now. And in case you have any questions, just leave them in the comment section. I'll be glad to reply to them as soon as possible. Okay, now let's proceed with this problem or this concept of what reversing order. So let's say you have what a question like what the integral of what maybe from 0 to 2, and then we have maybe y on 2 as the upper lower limit, and then we have 1, and then the main question is what x exponent 2, okay, and then we have what dx dy. Okay, this is the main question. Okay, this is the main question. Now we want to reverse the order so that we try solving it with a different approach. Okay, so for reversing order we have maybe type 1, type 2. Okay, but for this question we'll be using what type 1. So for type 1 we'll be using what respect to what dy. So let's say we want to treat, okay, let's treat dy as type 1. Okay, let's treat dy as type 1. Okay, so for treating dy as type 1, all we are trying to do is just replace or interchange the dy with dx. So this is how the it will be. So you interchange dy with the x. Okay, so dy will come in front and then dx will go back, so that we first integrate the expression with respect to y first. After that we do that for what dx. But here's the trick. Let me show you something. So we know that the integral from 0 to 2 corresponds to what? From 0 to 2 corresponds to what? Dy. Okay, dy. And then the integral from 1 to what? Y on 2 corresponds to what? Dx. Okay, so sometimes you can come across these kind of what integrals where you will need to take the reverse because some of these limits do not add up. Okay, so from here you can notice that dx has the limit of what y on 2 to what 1. Okay, where dy has a limit from 0 to 2, because from here you notice that this is quite okay, but for the dx it's not that much, because we are using what dx but we have what y, okay, to do the substitution or as the limit. So all you have to do is just interchange what, or just take the reverse. That's where we have what reversing order of what integration. So this is what you have to do. So we know that from 0 to 2 corresponds to dy, and then from y on 2 to 1 it corresponds to dx. Now once you try to do the reversing, we know that y1, okay, let's say y1 is equal to what 0, and then y2 is equal to what 2. That's from here. And then from here you know that x1 is equal to y on 2, and then what x2 is equal to 1. So when trying to do the reverse, take note of this. Okay, take note of this. We are trying to reverse this side. Okay, interchanging dx with dy and then y with dx. Okay, dy with dx, that's vice versa. So from here you can notice that this is quite okay. We don't have anything like y1 is equal to x plus 2 or x or anything of that sort. But from here you have what x to be equal to y on 2. Okay, but we are dealing with what dx, not y. So what you can do over here is that you have to make y the subject. Okay, so making y the subject, from here we have what y is equal to what 2x. Okay, so from here we have y is equal to 2x, and then we have x2 is equal to 1. So just from here you've been able to do the reverse. Okay, so this is what you have to do. Just rewrite this one out. Okay, these are the limits, and then we have what e exponent x squared. Now for interchanging, from here you know that we have what dx dy, but doing the interchanging, this is what you have to do. Just this has to change what dy dx. Now we start everything from 0. So from here we have what this for dx, okay, the limit for dx is from 0 to what? 2, okay. So we are doing the interchanging, okay, from 0 to 2, okay. And then for the limit for dy is now what? From 0 to what? 2x, okay, from 0 to 2x. Okay, so this is how you do your what? Your simple what? Reversing. So after you've been able to go through this, you can just now take what? The integral. So taking the integral with respect to this, okay, we have what? E exponent what? X squared dy. So just integrate. So when you integrate e exponent x squared, you end up with what? E exponent x squared y, okay, and then you have what? Your limits, that's 2x and then 0. So all you have to do is just substitute, okay. So we have what? E exponent x squared multiplied by what? Y, which is what? 2x minus what? E exponent x squared multiplying what? 0, okay. So from here you notice that the final answer will be what? E exponent x squared multiplying what? 2x, because this will go to what? 0. The entire of this will go to 0. Now from here you could notice that you can just use what? You can now take the what? The integral respect to what? X. So for the integral respect to x, that's from 0 to 2 from here, okay, from 0 to 2 from here. So you could notice that this was maintained, okay, for the what? X, okay, that's the first one, it was maintained. But for the second one, we try to reverse this with respect to what? The what? Corresponding what? Dy, okay. This was just maintained because we didn't have a situation where we had maybe x divided by maybe 1, x divided by maybe 3, or x plus 2, or anything of that sort, okay. But this portion had what? Y on 2, but it was just corresponding to what? Dx, which we didn't want, okay, which we weren't interested in. We were interested in something corresponding to x or corresponding to y, okay. So something like limit from 0 to 2 could correspond to both the x and the y, but limits like y on 2 on 1 cannot correspond to dx. It should correspond to something like what? Dy, which wasn't for this case, okay. That's why we did the reverse. So in case you don't understand anything, just let me know in the comment section, and then I will try explain further, okay. So from here you just maintain this expression. So we have what? X squared, and then multiply by what? 2x, and then this will be what? Dx. So you can notice that now everything is now in what? X, okay. That was what I was referring to. Now you could just find what? The integral, okay. So finding the integral of this, you end up with what? 2x on what? 2x, okay, and then you have what? E exponent what? Squared, and then you take the limit from 0 to 2, okay. That's where you integrate ex squared. Note that this is the same as what? This is the same as from 0 to 2, and then we have what? 2x, okay, ex squared, or okay, or you could just write this as what? 2x, okay, and then we have what? The limit 0 to 2, and then we have what? E exponent x squared, okay, dx, okay. So you could either write it this way, okay, this way, or this way, okay. You end up with the same what? Expansion or integral. So from here we have what? The final answer being what? E exponent x squared with what? The limit from 0 to 2, because these ones will just cancel out, and then now we have what? E exponent what? 2, okay, exponent 2, and then we have what? Minus what? E exponent what? 0 exponent 2. So when you do the computation, you end up with what? E exponent what? 4 minus, so E exponent 0, note that E exponent 0 is always what? 1, okay. Keep that in mind. E exponent 0 is always 1. So from here, you can notice that we found the final answer. This is the final answer for the entire question, okay. This is how you do what? Reversing order, okay, reversing order of integrals, okay. I hope this was helpful, and in case you have any questions, again, just let me know in the comment section, and then I'll reply to them or explain further for your understanding. I'll see you in the next video, where we'll be treating other concepts under what? Integration. Have a lovely day.